Welcome back, nerds. Today we're going to go ahead and jump in to 1.4. We're going to get a start on it. We're not going to finish. In 1.4, we are going to talk about a type of logic that you guys have used over and over, and we're going to be looking at inductive logic. Now, normally, I will have it, and then we'll have a bullet point. This is going to be the same as the bullet point. We're going to just sneak the definition in here. So inductive logic is our focus here. Okay, by the end of the lesson, you're going to be able to make conjectures and counterexamples for induction. Like, that's our end goal. That's how you'll be able to show that you know this stuff, which I don't know. Anybody know what I just said? To make a conjecture, do you know what I'm talking about? How about a counterexample for an induction? Probably not. Like, some of it you might know, but we're going to get all that in. So right off the bat, you guys have used inductive logic your whole life. We just used it to predict the sun, and hopefully we're right. You used it earlier to, I assume, come up with 32 as that pattern. That was induction that you were using, but you were wrong. It is a valid proof technique that we're going to use in geometry, just kidding, that we're going to use all over life. But it really, really kicks in later math classes. Pre-calc is the first time that I think we use like hardcore induction stuff, and it's awesome. We'll see it eventually. So, for our purpose, just right off the bat, let's define this. All inductive logic is reaching a conclusion. And just so you know, conc, C-O-N-C, I'll cut it off right there with a, like, that's my shorthand for conclusion. Reaching a conclusion, weird, from previous observations. Now, you can't just guess something random. It's observations. If you mouth off to your parents, are you going to get to do something fun? Probably not, right? Like, have they ever told you that that's the exact rule? No. Probably not, but you've done it before and you've been punished, so you know that the rule is there, right? Okay, this is induction. We use it all the time. Now, when we look at this, our first topic is just going to use induction. And we're going to jump right into some Algebra 1 stuff. Or Algebra 2, which there's going to be times if you're doubling up that this happens. We're going to do an example. Everybody in here has seen Algebra 1. Here's all I want you to do. I want you to predict the next three terms in this list that I give you. So almost identical overlap for a minute, Ronaldo and Liam. Anyway, here we go. All right, let's make a pattern here. 2, 10, 18, 26, ... I want the next three numbers. Don't just shout them out. I think that you're going to come up with some way to do this, whether you talk with somebody or not. If you need to quietly chat, I'm cool with it, but don't shout it out for everybody. Go, find me the pattern. Next three. All right, so if we're looking without talking about it, 34. Cool. Next. 42. I think I agree. We all said the same thing. And 50. How on earth did you get that? Oh, they're just adding 8 each time. Okay. Cool. Is it possible that that's not the pattern? It's possible, right? Because we just saw an example earlier where the pattern looks really clear and obvious, and then it's not. But this seems reasonable, yeah? Do you guys remember doing this in Algebra 1? Okay, you might have seen it written like this, a sub n equals and blah, blah, blah. Okay, now it looks familiar. All right, should we do a harder one? No. Really?
Yeah, we should.
Okay. Check it out. On B, a little harder. I want to start at 0. Scratch that. I'm just going to cross it off. Or make it sad now. There he is. All right, we're going to start at 1, I suppose. Then it's going to be a 2. Then it's going to be a 5. Then it's going to be a 10. Then a 17. A 26. Can you give me the next three terms of this one? I'm going to pause it. I'll give you another minute. A little harder. Our focus is not on just being able to find it, but if we can try to find a pattern, we're using induction the whole way. Try it out. Talk it out. About 1 minute. There is a pattern. There is a specific answer I'm after. You may see it. You might not. Okay. Either way is okay as long as you're trying something.
1, so adding 1, 2 minus 1 is 1, 5 minus 2 is 3, 10 minus 5 is 5, 17 minus 10 is 7. So 1, 3, 5, 7, 9. So it's gonna go up again 3. So then it goes up like 9. Yeah, it's gonna be 12. That makes sense. Wait, what? Oh, so every number. So 2 minus 3 is negative. So it's like you're counting by threes, and every time you count by threes, that's the number you add to the number that you have. And so what? Yeah, because look, 2 minus 1 is 1, 5 minus 2 is 3, so 1. But what about 1? And 10 minus 5 is 5, 1, 3, 5. 17 minus 10 is 7. So 1, 3, 5, 7. What? How do you get?
I'll do the same thing with this.
1, 2. 2 minus 1 is 1. To get to 1 to 2, you have to do 1. So that's a pattern of 3, just 1. The next number 1, 3, and then the next one is 3. Because to get from 2 to 5 is 3, 1, 3. Okay, but then 5 to 10, that's 5. Yeah, that's 5. 1, 3, 5. You're counting 5, 1. It's odd numbers.
Okay, so at this point, Henning, I'm going to call you out because that was awesome. Henning came up with a good observation. He was sitting there, and I gave a hint over there. I don't know if you guys were able to run with it or not. Okay, we have 2 ways to get the same pattern. Henning, can you walk me through what you saw? So here's plus 1, and then plus 3, plus 5, plus 7, plus 9. What do you think the next term is going to be? Plus 11, right? Is so there's another way. That's 37, yeah? And then the next one would be plus 13, gets me to 50. So 37, 50, and 65. Check it out. That is not what I used to generate this pattern. I'm going to keep you guys for about 10 more seconds. What's 0 squared? 0. Plus 1. 1. What's 1 squared? 1. Plus 1.
1. 2.
What's 2 squared?
2. 4.
Plus 1? Oh, what's 3 squared plus 1? 4 squared plus 1? 5 squared plus 1? Okay, different patterns from different points of view. I love it. We're all inducing right now. We will run with this idea tomorrow. I'm not going to update the classroom with this exactly, but what is due tomorrow, Klein? Homework. If you need a place to work, study hall is in here today. Cool. Thanks again. Sorry, I forgot to take that earlier. Or throw